Welcome to this wonderful tutorial. In this video, we're going to do question 10, which is the last part of the tutorial sheet. So, as you can see, this question looks to be the same as the one we did previously. Let me check. It is actually this question because this was moving east, this was moving north. Okay, so the same way we dealt with this question, the same way we're going to deal with this one. So, I ask you for your total attention. So, we have been told to say that a 90 kg fullback learning east. Okay, as you can see, it is learning east. Okay, then what have we been taught about this thing which is running east? It is running at an angle of, at a speed of this, then it has a mass of 90 kg. Then is tackled by a 90 kg. It is tackled by a 90 kg opponent running north. So we have another opponent which is running north. As you can see, it is running north. It is moving in the north like this because this is the north direction at a speed of 3 meters per second. Okay, then the mass is 90 kg. 95 kg. Okay, so with this information, if the collision is perfectly inelastic, meaning these two cars, these two objects are stuck together, okay, in the collision. So now, what you need to understand is that these two are in different direction. The one is going north, which is like in the y direction. The one is going east, which is in the x direction. So what I told you is that we are going to find the momentum in the x direction. This momentum in the x direction will be the momentum for this object, okay? And the momentum is given by mass times velocity, but this velocity is going to be the vx because it is moving in the x direction. Okay, same applies. We are going to find the momentum in the y direction, which is going to be m. Now vy for this velocity in the y direction. Another thing I told you is that when an object is moving in the east direction, it is at an angle of 0. And when it is moving in the north direction, it is at an angle of 90 degrees. These are found when you are moving anti-clockwise. Okay? Because when you are moving clockwise, this is now going to be 360. And here is going to be 270. I showed you guys when we were dealing with vectors on how we can find a direction clockwise or anti-clockwise. So the Vx is given by, we're going to have Pxm. Now the Vx will be now given by V cosine theta. Okay? Of which we're going to have mv cosine 0. Cosine 0, we are using this one. Cosine 0 is just is 1. So our px is going to remain with m times v. Okay, so our px is going to be equal to, our mass is 90, then our velocity is 5. So our px will be no other than, even without a calculator, we know that this is 450 kg meters per second. So same applies to here. We use the same. Our y component is going to be equal to, for this which is going in the y direction. So our mass is 95. Okay, then vy will be now v sine theta, but this v is not 5, it is this. Okay, so py is equal to 95 v sine 90. Okay, we are using this sine 90 or sine 270, it will give you 1. So our py, because this is 1, we are going to remain with 95 times v, which is 3. Okay, so our y component is going to be equal to 285 kg meters per second. Okay, so now to solve, take note px 450, py 285. So to find for the momentum now, we are going to use the formula for finding the vectors using the component of px squared plus py squared. So get our p is going to be equal to, our px is 450 squared plus 285 squared. So our momentum is going to be equal to 532.8 kg meters per second. Okay, so this is what? This is our momentum. Now, after finding the momentum, that means we can find now the speed. Okay, we can find the speed. We know that the momentum now is given by mass times velocity. But this mass, because the collision which occurred was inelastic, it means we are going to add the masses. Okay, we are going to say our momentum now is going to be equal to m1 plus m2 over v. Okay, so to get rid of this, we divide by m1 plus m2. This will cancel, as we are also doing the same here. So our velocity is going to be equal to total momentum, then m1 plus m2. So our total momentum is going to be equal to 532.8, this over the summation of the masses. The first mass was actually 90, the other one was 95. So our velocity is going to be equal to 2.88 meters per second. How can we find the direction? Okay, to find the direction, we are going to say the direction is equal to inverse tangent of the y component of the momentum over the x component. Okay, so the inverse tangent is going to be equal to, the y component was giving us 285, then the x component 450. So we have 285 over 460. So sorry for that line. I wasn't actually cancelling. Just okay. So 285 divided by 450, we get our answer to be. So this is our x component over. So we need to use the y component. The y component is for this. Let me check. So this was moving east at this, so it's the one with the x component 450. Then we have the one with the y component 285. So we are just okay. We said 285 over 460. Okay, so 285 285 we divide by 450, we get our angle theta to be tangent inverse of 0.63333, going like that. So now we can say that the inverse tangent of 0.633, our answer is going to give us 32.3. Okay, and right, this is our answer. We can't do any further calculation because you know that the y component is positive and the x component is positive. So this is our angle theta. Okay, this is our angle theta moving in the direction of north of easts. So thank you for watching this video till to the end. If you find the video help, please consider subscribing to the channel. Subscribe to the channel. You like the video, you also share so that it may reach other audience who may need help just as you are. So thank you for watching. See you in the next video. Okay, I wanted to write something wishing you of something very, very important. I wanted to write, wow, all the best. Okay, all the best in your upcoming exams and tests which you are writing very soon. So thank you for watching. See you in the next video, guys.